And for our third example, we have the run function. The Laplace transform of t and u of t. We have the improper integral of t u of t times e raised to negative st dt. And since we have a combination of two different terms, we will use the integration technique, integration by parts. Having the form of integration by parts, we have the integral of u dv is equal to uv minus the integral of v du. Identifying our u and v. We have t as our u, and having the derivative of t, du is equal to dt. And our dv is e raised to negative st. Having the antiderivative of e raised to negative st, we have 1 over s, negative 1 over s, e raised to negative st. And putting it in the form of integration by parts, we have uv negative t e raised to negative st over s with the limits of 0 to positive infinity minus the integral of, improper integral of 0 positive infinity times 1 over s e raised to negative st, don't forget the negative sign, dt. And we'll first evaluate our ub form and substituting the limits of 0 and positive infinity, we have 0 minus 0, since infinity over infinity is equal to 0. And we have minus negative 1 over s. Since negative 1 over s is a constant, we put it outside the integral. And evaluating the integral of e raised to negative st, we have negative 1 over s e raised to negative st. Still having the limits of 0 to positive infinity. And simplifying our integral, we have negative 1 and since this is equal to 0, we will distribute our negative sign, having 1 over s without the negative sign anymore, and negative 1 over s with the evaluation of the limits of 0 to positive infinity of e raised to negative st, we have 0 minus 1, and leaving it with 1 over s, since 0 minus 1 is equal to negative 1, multiplying negative 1 over s times negative 1 gives 1 over s, or positive 1 over s. And therefore we can have that the Laplace transform of tu of t, or a run function, is equal to 1 over s squared. So this is the Laplace transformation of run function in the complex frequency domain.